Hello and welcome to Lecture 5 Quiz Explanation. I'm joined today, we have me, yours truly, and my TA Enoch. Smile and wave, Enoch, smile and wave. Yeah, okay, so as you can see, we're filming here in the glorious Ikea, right? Because it's very boring to film in the office, at home, and in the studio. So yeah, let's have some fun filming, shall we? Well, okay, this is the first time we're doing outdoor shoot. I'm not sure how far we can go filming all these things until they kick us out, but let's begin. Alright, let's go.
Let's take a look at section 1. So actually, if you look at this section, most people got it wrong because they chose a wrong option, which says the rule chosen for the greedy method can be changed multiple times while the algorithm is running midway to solve a problem. Now in fact, when you have done this kind of ad hoc, if this scenario use this rule and if another scenario use another rule, you're no longer using the greedy rule. Over here, we just want a simple greedy rule that you can apply consistently across the entire scenario.
Okay, so now let's talk about section 2, okay? The question is like, which of the options below depict several scenarios that contain both a problem and a solution that features the use of the greedy method. Now, don't forget, greedy method, the word greedy is the heuristic. Now, what makes a rule greedy? When we use words like smallest, biggest, latest, earliest, most, or least. So if you follow this heuristic, then as long as your sentence contains words like this, your rule is greedy.
Section 3. Now this section asks you to find the most effective solution in terms of greedy method. And if we look at this, actually what we realize is that the most effective solution for greedy method is actually to arrange the members by number of preferred genres in ascending order, not descending order. If you have arranged them in the descending order and you actually work out the entire problem using this greedy method, you realize that it's actually more inefficient as opposed to the first solution. So that's why the ascending order is actually important here.
Okay, so now let's move on to the next section. The next section requires you to execute the greedy method. Okay, so don't forget the greedy method. What is required for this greedy method? Assign 2 books according to the preferred genre to the person with the lowest number of preferences. Okay, 2 books from the same genre, and if that's not possible, assign 1 book per genre by alphabetical order. So this is where a lot of students get the question wrong, because they did not pay attention to the assign the book by the genre by alphabetical order. So if you have pay attention to that little detail, then you have gotten the right answer.
So the very first thing that we need to do is actually to arrange the members by the number of preferred genres in ascending order, followed by alphabetical order if the number of genres are the same. When we do that, we get something like this. Now that we have done this, we can move to the actual greedy rule itself. The greedy method says this: assign 2 books according to preferred genres to the person with the lowest number of preferences first, 2 books from the same genre, and if that's not possible, then assign 1 book per genre if books are still available for that genre, and genres by alphabetical order. And you repeat the same method of assignment to the person with the next lowest number of preferences, and so on. So, looking at this, we begin with Donald, who has fantasy only. So we will assign him 2 of the fantasy books. Now the next person that we need to deal with is Roddenberry. Again, he can only take science fiction, so we'll give him 2 science fiction. The next one is Lewis. Now for Lewis, we are going to give him 1 fantasy book and 1 science fiction book. Now, why is this the case? Of course, it's simply because there's only 1 fantasy and 1 science fiction book left. So following the greedy method, we're going to assign Lewis 1 from each. Now for Martin, on the other hand, we're going to assign 1 mystery and 1 romance book. Notice again how we have used the genres to come first. It's in alphabetical order, so M before R. Now we move on to the case of Jane. Now Jane can take both classics and comedy, but given the rule where we talk about alphabetical order of genres, classics will be assigned first. So Jane will get both classics, and Agatha will get both remaining comedy books. On to section 5. Now if you look at this question, Actually, most of you got this correct, but for some of you, this was a little problematic because you actually chose to come up with your own more efficient greedy rule than what the question actually gave. If you follow the rule strictly, you will find that actually you need 7 weekends to finish watching all 12 shows on a list. But of course, some people decided to take matters in their own hands and they came up with a more efficient greedy rule that requires only 6 weekends.
Alright, now I'll be doing the demonstration for the net flop question. Yeah, the first greedy rule, which is actually a very inefficient greedy rule. Okay, so the greedy rule states that on each weekend, watch the longest show, and if it doesn't exceed your 50-hour binge limit, watch the shortest show. If you notice, this only allows you to squeeze 2 shows per weekend. So we have weekend 1. Okay, weekend 1, we put in the longest, 49, and then we cannot put in the shortest, right? So now we move to weekend 2. Weekend 2, we can put in 41, and then we can put 3, right? So here's the thing, the greedy rule says that you're supposed to only put in one longest, and if there's space, put in the shortest. So therefore, we now move on to weekend 3. Okay, so weekend 3, I take 37, and I put the 5, 37 and 5. Then weekend 4, I will put 35 and 7. And 7, weekend 5, I will put 33 and 14. Weekend 6, I will put 29 and 15. And weekend 7, I will put number 16, which is Star Wars. Da 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 da. Okay, and now on to the next section. Now, in this question, we ask you to identify the pseudocode that correctly executes the greedy rule in the previous section. So there are actually 2 correct options. There is a third option. Okay, we are moderating this question because so everybody that attempted this question will get 2 marks, yeah, the 2 marks. Why? Because one of the options, there was some ambiguity. Let me zoom in on that option. Do until there are no unconsidered shows left. Allocate the longest unconsidered show to the current weekend. Mark the longest unconsidered selected show. So this causes some confusion. If we didn't have the word selected, then yeah, the algorithm will work as planned. But because of the word selected, that is if you follow the wording very strictly, right? What happens? Then you know that the machine wouldn't know what is being selected at the moment, right? Okay. So because of this ambiguity, we will moderate this question.
Okay, on to question 7. Now the thing is, for this particular question, chances are you have gotten it wrong if you carried forward your mistake from the previous question 2 questions ago, where you actually interpreted the rule with your own rule instead of using the rule as written. If you compare the 2 rules given here as written, you will realize that in fact, Greedy Woo's greedy rule is actually more efficient than the rule as written from 2 questions ago.
Okay, so here is the demonstration for Miss Greedy Woo's greedy rule. So her rule says watch the longest show that you have not watched, and then if there is space, you fit in the next longest show. Alright, so we will put in 49. So first weekend 1, we'll put in 49. Alright, can we fit in any more? No. So we move on to weekend 2. Weekend 2, we'll put in 41. So that gives us space for 9 more hours. So what's the next biggest? 7. So we put in 7. So cannot fit in anymore. Now we go to weekend 3. Weekend 3, we'll put 37, and we're left with 13. Okay, so we have space for 13. We can't put 15, 14. So the next biggest will be 5, and then we have space, so we can put in 3. Alright, so now we're done. So now we load weekend 4. Weekend 4 will load 35. So 35 will give us a space of 15. And then we can put in 15. So 35 and 15. Okay, now we cannot load anymore, so we'll go on to weekend 5. And then we'll load 33. We have a remainder of 17. So 17, the next biggest is 16. So you can put in 16. And weekend 6, we will put 29 and 14. 29 and 14, and voila, job's done. So here is a side-by-side comparison. You can see the difference. This one takes 7 weekends, this one takes 6 weekends. Yeah. Okay. Is this better?
Yeah.
Okay. Okay, so moving on to the next section. Okay, in this question, we want you to identify the pseudocode algorithms that will correctly execute Miss Greedy Oo's greedy rule. Alright, now if you pay attention to the algorithms in the options that we present to you, you notice that there is no select something 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 as the current something something, right? This is our way of showcasing to you that there are more than one ways to achieve the same thing. Yeah, so in this case, you can just allocate to the longest, and then since longest is our reference already, right, then we can mark the longest as done. Alright, so okay.
Okay, on to the next section, section 9. Now, if you look at this question, most of you actually got this correct, and we have been lenient in giving you partial marks as long as you got at least one correct answer. However, some of you will have missed out some of the correct options, and chances are if you did this, it's because you may have done the working but done it incorrectly so that you didn't get the correct answer in the end. Now, the three correct options are these. First of all, the algorithm will not effectively minimize the difference across all children in the total sum of the goods received. The first child will always end up with the highest total monetary value, and the last child will always end up with the lowest total monetary value.
Oh, hello, I was just baking some delicious apple pie. Okay, now, so let's move on to the next section. The next question is asking, right, you had an intern that's proposing a better solution, right, a better greedy rule. So, but then your intern actually fainted while on the job. So, let us complete what is the greedy rule that this intern is trying to propose. Well, the answer is that it is the child on the list with the next lowest total value of inherited goods. And if there's a tie, we break tie by ascending order on the list of children. That means if child 1 and child 2 have the same value, then you give it to child 1. Yeah. Now, this one, if you're not sure, you have to work it out by hand. You work out all the various options, and then you'll see that this actually produces the most efficient solution.
On to the second last section, section 11. Now, this question requires you to use an algorithm to select the correct algorithm that will fit the intern's greedy rule. Now, if you look at the three different algorithms, only one is the correct answer, which is to do until all items are marked considered. Select the most expensive item not marked as considered as the current item. You'll find that one of the incorrect answers forgot to do this. This will result in an infinite loop because you always choose the most expensive item whether or not it has been considered. Next, it will say select the child with the lowest total value as current child. Of course, if you selected the wrong option that says select the child with the highest total value as current child, you are no longer using the intern's greedy rule.
Okay, so we're now at the last section, section 12. This question requires us to do the working for the greedy rule so that we can find out which child gets the what?
Let's switch how much money.
Okay.
So what will this look like? For example, you start the largest value, 5.4 million. This one will go to child 1. The next highest is 5.3 million. 5.3 million goes to child 2. And child 3 gets 4.9 million. Now what happens at this stage? We will go to the child with the lowest value. So child 3 will get the 4.2 million. Next, child 2 gets 4.1 million. And child 1 will get the 3.8 million. Okay, now remember at each stage we need to calculate and update the total number that each child has. So how much does child 1 have at this point? Child 1 has 9.2 million. Child 2, on the other hand, has 9.4 million. And child 3, he has 9.1 million. So who has the least now? It's still child 3. So child 3 will get the next sum of money. Then we move on to child 1. 2.9 million will go to child 1 and 2.1 million will go to child 2. At this stage, again, we need to take stock of where we have come. Child 3 now will have 12.6 million. Child 2, on the other hand, has 11.5 million. Child 1 has 12.1 million. Now, who has the least? child 2 has the least. So child 2 will get the 1.9 million. That leaves child 1 with the 1 million and child 3 with the 0.9. After having come this far, child 3 now has 13.5 million. Child 2, on the other hand, has 13.4. And child 1 has 13.1 million. So the one with the least is child 1. Child 1 will get the 0.7. Child 2, being the next least, will get the last remaining 0.1. So in the end, child 1 will have 13.8 million. Child 2 will have 13.5 million, and child 3 will also have 13.5 million.
And that is how you optimize. So I hope you had fun learning from us through this Lecture 5 quiz explanation. This was really a crabby attempt at entertaining you, explaining the quiz answers. Well, I hope you had fun. So stay healthy and as always, stay crabby.